Okay, hi everyone. Today I'm trying to practice something I'm not so good at, and that is showing off and narrowing down the things that I've already worked on. And so I guess this will be, in a sense, a devlog for a particular project I'd been working on, which was a few months back. I became like ADD, hyper focus, obsessed with developing a fan made Mistborn uh, game in Unreal Engine 5. And, it was also just a good excuse to learn Unreal Engine 5. And so I kind of dropped the project about as quickly as I had started it. So I probably worked for about 3 weeks or so, and then I just dropped it entirely. And this must have been back in, I don't know, August or September, sometime around then. Yeah, so this will be about as much of an exercise for me in remembering exactly what I did and how I did it, so that I can show you how it was done. For your sake, your viewing sake, maybe you'll even learn something, and I will teach it well enough. But anyway, just a quick demonstration of what we have here. So there's a bunch of debugging up there. First off, I did, after developing my own movements in locomotion system, I just went for implementing the advanced locomotion system, which also allowed me to take everything that I learned and to re-implement it at a more refined way after having, gotten more familiar with the engine. So yeah, advanced locomotion system, obviously. I mean, we have this lovely run walk animation. I think you can walk. Oh, what did I do? Yeah, you walk by pressing Alt. It works so well, Oh, we got some ray tracing here. I'll have to turn that off. But what makes this Mistborn specific, at least in terms of what I was developing, was we have this kind of sensing mode where it makes everything quite foggy, and we have highlights on specific pieces of, if you read the books, it would be metals, and hovering over these, it turns it into a different color. This was a good exercise in shaders and such, and it doesn't work exactly as I would like it to. I would have loved to have had it so the actual value, what am I thinking of? The amplitude, like the brightness of the shader, would fade over distance, but just by the inherent nature that you can actually get like an outline in Unreal Engine, it didn't seem very plausible. So everything is kind of uniformly outlined, but it works. At least for this kind of proof of concept I was trying to build out for myself. But if you have read the books, if you haven't, I'll give you a quick rundown. The idea is these Mistborn are people who can push and pull on metals, and if you push on something that's heavier than you, then you will move, and if you push on something that is lighter than you, it will move until it hits something heavier than you, in which case you will also move, or it will move you both if it's close. If it's encountering friction, it may be moving both of you in a sense, like a force pushed on both. And it's all this vector-based kind of center of gravity, physics-based magic system, which is why I had enjoyed the book so much. But just a quick example. Let's go ahead. I think it's E. It's been a while since I've done this. Yes, E will push, and as you see, it pushes me back as well. And then once it gets completely, there, it's just goodbye. There I go, off into the sunset. This is obviously still requiring some refinement because the force is supposed to die down as you get further away from an object. It's not supposed to inflict the same amount of force as if you were right next to it, and that's just the limitation of an individual's power, but also just the calculation of friction. I think I need to make it more more lenient, more user-friendly, to make more fun in a game sense. And at the same time, I also want to create a sliding animation, which, you know, I think would just, but that's going to take a lot of work. I think it would add a nice sense of, you know, cohesion with the game systems and the actual look of the character. But yeah, so that's pushing. There's also pulling. And the idea, these bars up here are stable, and so because I have these set to anchored, if I push on them, I will move, and if I pull on them, I will move back to them as well, albeit very slowly. That was kind of strange. Again, it's been a bit of a while since I've actually worked on this. That ray that you're seeing, by the way, is another solution that maybe I'll get to in this video, maybe I won't. I think mainly in this I want to touch on the pushing and pulling. So you can select multiple objects as well, because that's something that they do in the books a lot. So here, if we have two objects selected and we pull on them very strongly, ideally the ideal outcome of what will happen, which again I think a lot of this needs refining, but the ideal outcome is, yeah, the equal pull will have us floating between the two objects. However, I do not know why this is not equidistant. But, you know, actually maybe the physics is right and my hypothesis is wrong. Yeah, it's a bit of weird behavior, but I think I know why it's being weird, because if I remember correctly, I had done a lot of reworking on how you actually move with this pushing and pulling. We'll get into that in a bit. But, so actually, what I'm going to do is I'm going to draw something for you here. One moment. Hey everyone, real quick, this is post-editing me. I was going back and looking through everything, and I noticed that every time that I had mentioned calculating and applying a force vector to an object, I did not give you the proper rundown of how that is done in Unreal Engine. So I'm going to do that real quick before we get into every time I begin saying apply force to this object and I don't actually tell you how to do it. So let's say we have two objects here, and let's say we have object 1 over here and we have object 2 over here, right? And we want to apply a force onto both. Let's say both object 1 and object 2. Let's say we want this one to go this way and this one to go this way based on their relative center of gravity, right? So force applied on by two objects. What we would do first is we get the world location of this first object, and then we get the world location of this second object, which will automatically return based on the center of gravity. In Unreal Engine, although I believe I have it set to a custom object that is considered the center of gravity. What we then do is, given that, I believe it's a 3D vector, given that 3D vector, we subtract one from the other. So it's vector minus vector, and this vector that we get resulting, we calculate the unit vector, and what that is essentially is it is the direction from, well, okay, so if we do object 2 minus object 1, the unit vector that we will result is the direction from object 1 to object 2. And if we want it the other way, we actually have to do it the other way, which is subtract object 1 minus object 2. But another way you can do it is to just multiply the unit vector by -1. But essentially what happens is we get that unit vector, the direction vector for both. So for both of these, it would look something like this. They'd be pointing towards each other. And then we would take that unit vector, we would multiply it by whatever base value we want. Let's say we want it to move in 10 this direction. If you know what a unit vector is, it automatically has a magnitude of 1, so you already know that this is these both are magnitude 1. They just indicate direction. That's their purpose. So we multiply both these unit vectors by 10, and what we will get is a much bigger vector in this direction. And then, well, given that we want it to move the opposite way, we would multiply it by -10 because it's the opposite direction, because in this case they would be pushing on each other, not pulling on each other. So, you know, just pretend that I actually drew these going this way, oh my god, and not this way like a fool. And what we end up with is sadly still only a vector, a directional vector, this time times 10 magnitude. And so the last thing that we have to do is actually add this vector back to the world location of the object it's being applied to. So we get the world location of 1, we add this new 10 magnitude vector, we add them together, and we actually get the vector of this object moving that way at a magnitude of 10. And so anytime I from this point on say we calculate the force applied to an object and we apply it to it, those are the steps that are required to do it within, I would say, Unreal Engine, but also any essentially physics-based engine. It's a couple of steps. But yeah, on with the video. We got the good old paint open right here. So if you have, you know, let's say we have an object here, and we have an object here, and let's say this object is the one that will be doing the polling. So let's just label it with a P for, I don't know, player. And let's say that these are of equal, no, let's not say equal weight. Let's say this weighs, the P is heavier in weight, right, than this object right here, which will be pushed upon, right? So assuming no friction, no surface, no collision or anything, what would happen is, what I would do is I would take the distance between these two objects, so let's just call that D, and let's hypothesize for fun that this is a value of 10. We take this value of 10 and we would create a 3D vector and say that the force on the object is in the, let's do 2 dimensions for the moment actually as well. So we have x and y, right, in your normal standard algebra class. So the x direction is 10 and the y value is a good old 0, right? What's interesting about this is, you know, I would return 2 values in this function here, where this would be the force, let's call it F2O, the force to the object, and then we also have the F2P, which would be the opposite. It is the force to the player. And both of these are returned when calculating the force, right, in terms of what is being enacted upon and by how much. And actually it's one step more complicated. I seem to have forgotten this, that there's a variable within the Mistborn player class blueprint called, I believe it's push power, and push power will multiply these values by any number, you know. It depends on what I have it set to. I think I have it set to some outrageous number just for the sake of testing, you know. But obviously that would change. And I also believe, we can go and check in Unreal Engine right here. We can open the ALS Mistborn blueprint here. I'm pretty sure there's even some distance calculation. So tick, push, pull. I believe this is the manager for every tick, the value of pushing and pulling, and it is quite messy. This looks like one that I have not cleaned up yet. Most of these I've cleaned up and made them look nice, but it looks like, you know, as long as there's selected items in that item select mode, then it's going to go through each of the items. It's going to calculate the force of the object, which is really just a method call. And you know what, we can actually step into this. What this is going to do is it's going to get the mesh component, it's going to calculate the distance from the player to the object, it's going to get the location to do all that. Calculate resistance is another function, which I believe is actually, all it's doing is returning Oh gosh, no, this is another complicated function. This is returning how much force is... Oh, what did I do? Is this it? What is this? Apply force to object? No. Oh, now we're in the metal blueprint. Oh my gosh. This was the calc resistance function, yes. What this does is it calculates it takes how much force is being applied to it, and it compares it with how much is actually being moved in the physics simulation of Unreal Engine, and it's taking the difference between the two to return its theoretical resistance, because I believe the Unreal Engine physics engine already does, friction calculations on its own, but I don't know if there's any way to actually get the exact friction value for, you say, this object has this weight and its surface area is hitting this much. How much is the friction? I mean, you can calculate that on your own in the blueprint, of course, but I don't think there's like an API for the Unreal Physics Engine. So we kind of do this workaround way to get a base value resistance to see how much it is being resisted, and this is actually clamped to a value between 0 and 1. And so the idea behind it is if there was a wall here and this was unable to move and this force was still being enacted of a value of 10, then the resistance for this object would return 1, right? And then this force would therefore go all to the player. But I think the way it's currently set up now, which let's go back to Unreal, is that what we have, I think it's a percentage if I remember correctly. So we take the resistance factor, right, and then we return that. And this is in the calculate force. Yeah, so this is all happening within the tick, push, pull, which is, yeah, this right here. So that's all happening within here. And then I believe what we do is we apply the percentage, from 0% to 100% of how much percentage of the force should be applied to the object and how much should be applied to the player. Although, now that I'm thinking about it, that should probably be all force applied to both. All force applied to the object and then force only applied to the player. Well, no, the force should be applied to the player. The player just shouldn't move so long as the player is heavier than the objects being enacted upon. Okay, so, whatever. We still have some things to revisit upon, and like I said, it's been a while since I've actually worked on this. But what we do is we take this object. It looks like we're doing some math here. I believe this is... yes, okay. Oh, what did I do? It looks like what's happening here is it's taking the resistance factor, it's multiplying that by the actual force we're applying to the object, and then it's multiplying it by this modifier. I'm not sure what this is. That's weird. What is this modifier? The modifier is max push distance divided by the distance, and then it's 1 minus that multiplied by the unit vector. This is most likely a distance interpretation, but this will definitely need to be revisited because this looks whack to me. But anyway, back to business. So, apply to distance, in the sense of the further away you get from the object, the less force is being enacted upon by both, until eventually it's just 0. And then, what is this condition here? Oh, whether or not it's being pushed upon or pulled upon by the player. So this is where this is the next part I wanted to talk about. Okay, so depending on whether it's pushed or pulled, it's the same process either way. It's just the direction, and you see that here. We multiply the vector, the force vector, by -1, right? So if we go back to Paint, all right, now that we're back in Paint, can I erase all this? Yes, I can. Excellent. So what I had originally done is, let's say, let's draw our player box here, and let's say there's a floor here with a metal box here, and let's pretend that these two objects are on the exact same plane, okay? So any downward force applied by the player in the Mistborn metal push kind of sense, it will not have any horizontal movement. It will only go straight down into this plane, and let's say that this is the floor, in which case it will not move. All of the force will be redirected back up to the player, okay? So what I originally did in the implementation of this was I would just take that force vector and I would just apply it to the player, just directly up. Let's say it's a force of 100. Actually, this would be 0, 100 if we do the XY axis. It's just 0, 100, apply it to the player bounces up, and bam, like it's all the way up. And then what we would do is I would do this every tick. And it actually worked for the most part. It was providing me with pretty good results. The only thing that was messing up from it was what would happen is if you had those two equidistant objects that were equally being pushed or pulled upon, the idea is I want the player character to hang between the two of them, mainly because I just wanted it to work in every instance. Like if this were an actual game and you told the player, hey, this is a physics-based, kind of vector-based magic system with metal pushing and pulling, I want it to just intuitively, like they have an idea and they can just go do it. And if it doesn't work in every instance of that, then it needed to be reworked, right? And the instance that I would use, I used a couple of edge cases, but that was one of them, and it was breaking under this implementation. This just apply it directly to the player interpretation, right? And so I changed it. What I ended up going with is I have a circle object, a spherical object called 2move. I think it's called 2move force. In fact, I have it on all metal objects as well, but I also have it on the Mistborn player object. And this is a hidden sphere that's currently set in the center of the player. And what it does is, here, actually, we need to take this whole thing and scale it down. Oh wow, paint is actually quite nice. What we actually do now is, rather than applying this force to just directly to the player, what we do is we move this 2move ball, TM whatever, we move it to the coordinates 0, 100. And we do this with the addition of every object that the player is enacting upon. So let's say, for instance, that the player was pushing on these 3 objects. Actually, ideally, the horizontal force of these would cancel out, and we would add it all together. And the 2move object, it'd probably admittedly be higher, but let's say for the sake of argument that it would just be directly above you, right? This 2move object. It says, based on the location of the player and the 3 objects being enacted upon by this, magical force, we would want to move the player here. Then the very last stage of the tick is to calculate the force needed to be applied to the player in order to get them here. And the way that I did that was a simple vector addition. I remember I was watching a TV show with my roommate, and I was stuck on this problem of how to actually get this to work properly, and then I remembered my calculus course, and it ended up working. Let me draw this a lot nicer. So if you have the vector here, let's say this is the vector of the player to the 2move force, right? The player is currently moving down here because of gravity, right? We want them to be over here at the 2move, right? So what we need to do is we need to apply a vector force of this plus a vector force of this plus a vector force of this, right? Well, okay, this is actually, I'm going to backtrack a bit, and I'm sorry that I'm all over the place on this, but I need to backtrack a bit because the reason why this problem arose was actually because of what happens when you're in motion, in the sense of, oh, you're here, you're already in motion, let's say you're flying this way for some reason, and then you're being acted upon by these forces. It's like, applying the forces straight up plus this one, what it would do is it would just cancel this one out, and it would just boop, you just go straight up instead. And it was just unrealistic, right? So the idea is your 2 move force, let's say the player is heading this way already. That's what this takes into account. Whoops. The player's already in motion. It's going this way. M for motion, right? And then this is, well, oh god. All right. I'm going to redraw this. Player's going this way, right? The 2 move ball is actually over here. The idea is we need to get the difference. We need to get this vector so then we can calculate this vector. Because this is what the player velocity needs to be. We can get that based on where the 2 move ball and the player actually is. So if the player is already moving here, what we need to do is actually apply this force right here, this one, because the player's already moving this direction. And what made this so good was if the 2 move ball was calculated to be over here, but the player was moving way off in this left direction, which I don't have space on the canvas to do, it would just automatically calculate exactly how much force was needed to be applied to the player in order to get them to move towards the 2 move ball in a smooth way, because it would dampen initially, and then the 2 move ball is updated every tick, so initially it wouldn't just snap from left to right, it would actually change over time in a realistic way. My dog wants to go out, so to actually show you this in action, what I am quite poor. I told you guys this would be practice in explaining. It's really what I'm not good at. We can go to visible. Oh gosh, what is it? I'm just going to search it. Visible. Visible. There we go. And then I'm actually going to go to the blueprint metal, and it looks like, yeah, we have one here as well. It is called 2 move force. Remember, everyone, there's a difference between visible and hidden in game, because for some reason we need both of them. Alright. There we go. Okay, so it looks like the player is being forced over here, and the box was being forced over there. It stopped because I canceled the force. In fact, if I scroll, it should remove my force to very, very, very low. But yeah, if we pull them towards each other, you can kind of see the box being moved towards where I am. And then there's mine as well, being pulled slightly towards the box. And as I scroll and turn up the power, mine is desiring to be more and more that way. And this is modified. I scrolled all the way down, so the power is at 0. So that's that example. Now, whoa. That's kind of strange. Seems to turn down gravity for some reason. So, if I go ahead and pull on this object and scroll up a little bit, you can see how much that object is being influenced by me and how much I'm being influenced by it. And so the force is actually being applied to the player to move it towards that sphere. Whereas the sphere, what I wanted ideally was that the sphere would be still, but naturally that's not going to be the case, because depending on where you are and how powerful you are, like let's say for instance I was pulling on both of these objects at the moment from this position, the pull of this object would naturally be stronger. So let me actually, for demonstration purposes, go ahead and pull on both of these. What we would hope to see as I turn the power up, which we're going to have to wait a moment for everything to kind of stabilize out. But what we would hope to see is, yeah, for that ball to slowly, oh my gosh, yeah, this really needs some refinement. But the ball of the player should slowly move towards the center between these two bars. However, it's currently not happening. So I think this is just, okay, that was just too strong. Looks like it really likes this one. So you know what? I think you understand the idea of what needs to be done, but this is something I will refine and revisit. Overall, I just wanted to show how it actually worked in game. But that is most of the pushing and pulling physics, at least. Of course, there's more to this that I've developed, but I will do those in separate videos. So this is mainly just an introduction. I think next what I'll go over is animations, because there's a few things that I've done mechanic and purely animation wise in this that I have not shown that I would like to show. Yeah, so that's the end of this video. It was a bit long, it was a bit rambly, and for that I apologize. But yeah, I don't know. I hope y'all, if you're watching this, I hope you got something out of it. This is mainly an exercise in me practicing, describing things in real time and teaching you about what I've learned and showing off what I've done, which is a skill I woefully lack. So yeah, thanks for watching, and I hope to show you some more soon.